Hello guys, today we are presenting about distortion in welding. Let's introduce our group member. Hello, my name is Karvin Analanting. My matrix number is 05 DAD 22F1030.
My name is Roland Shoemaker Anali. My matrix number is 05 DAD 22F 103F.
My name is Ifwad Farullah bin Naim. My matrix number is 05DAD 22F1042.
Zimin, and my matrix number is 05 DAD 22F1059.
And now I go to the first slide. What is distortion? Distortion is a weld result from the expansion and contraction of the weld metal and adjacent base metal during the heating and cooling cycle of the welding process. Doing all welding on one side of a part will cause much more distortion than if the weld are alternated from one side to the other. During this heating and cooling cycle, many factors affect shrinkage of the metal and lead to distortion, such as physical and mechanical properties, then change as heat is applied.
Effect of shrinkage in various types of welded assemblies. The magnitude and distribution of shrinkage and distortion in amended structure are dependent on geometric parameter and the degree of restraint during welding. Geometric parameters such as the dimensions of structure and the type and size of welded joints, and welding parameters such as heat input, welding sequences, preheating and postheating will affect weld shrinkage and distortion.
Okay, today I want to present about these tips of controlling distortion. Number one, don't overweld. Overweld. The more weld metal we put in the joint, the higher the force causing shrinkage. Don't lay a 5/16 fillet when 1 per 4 fillet will do. If there is a drawing calling out welds, stick to the size called for. If necessary, invest in well gauges. You can learn how to use them to in proper use of well gauges. Number two, use intermittent welding. Using intermittent welding rather than continuous welds, where design allow it, can save as much as 75% weld metal and significantly reduce shrinkage and distortion. Welding stiffeners to plate is a great place to do this. Okay, number three, minimize the number of weld passes. The shrinkage caused by each pass is cumulative, thus making it better to fill the same volume in fewer passes, especially when we are welding in the trans transversal distortion. Number four, well near the neutral axis. As you can see it, the image below, the location of the well relative to the neutral axis will determine which way the structure will distort. If we can place the well right at the neutral axis, we can effectively control distortion. Okay, number five, balance well around the natural axis. We can always change the material thickness to affect where the natural axis is. In the case, whenever possible, balance the wells around the natural axis. This means trying to achieve symmetry. Number six, use backstep technique. This is helpful since the previous will create restrain minimizing distortion. The technique may not not be feasible in all situations. And the last, number seven, present parts of seed distortion. If we anticipate distortion and can predict which may the welding structure will bend, we can prevent the part so after the part is straight.
Today I will talk about method to controlling weld shrinkage. First one is tack welding. Tack welding straight through to the end of the point. It is necessary to damp the plates to maintain the joint during tacking. Next one is back-to-back assembling. By tack welding or clamping two identical components back to back, welding of both components can be balanced around the neutral axis of the combined assembly. Thank you.
And now we go to the end of the presentation. The conclusion from this presentation is we know dangerous distortion is so instant of death. We also learn about how to control distortion and always be careful in consideration of the welding environment. We should know how to matching welding process with material that we use. We must know a factor of safety applied to the design stress of the weld, which should be based on the sequence of weld felt and the level of NDT that is to be carried out.